Assalamualaikum warahmatullahi wabarakatuh. My name is Alisha Amira binti Nur Azlin, and my topic for FYP1 is the processing and analysis of recycled PLA filaments. This project is supervised by Professor Madya Dr. Muhammad Hussein bin Ismail. 3D printing is the technology of creating an object by printing layers by the deposition of materials. Many materials can be used for 3D printing, such as ABS, HDPE, and other polymers, but specifically for this project, we're focused on PLA or polyactide. PLA polyactide is a type of thermoplastic. It is general knowledge that plastic takes a long time to decompose, and specifically for PLA, it takes 80 years without any industrial intervention. Currently, plastics manufactured are marketed as single-use. Waste from 3D printing are generated from failed prints, support structures, and old materials. This waste generated can create a negative toll towards the environment. Hence, it is important that recycling can help create a circular economy for plastic and complying to sustainable development goals. The objectives of this study are firstly is to fabricate a recycled 3D printed PLA filament from the process of collecting, segregation, and extrusion of filaments, and secondly is to perform a thermal analysis on recycled PLA pellets and filaments, and thirdly is to perform a tensile test between the products of recycled PLA and the 3D printed products from the virgin PLA filament. The limitations for this study is firstly, only 100% pure PLA can be collected and segregated. Specifically for FYP1, I had collected PLA waste from companies. However, it's a mixture of PLA plus, Polymax, but after research, it cannot be combined and only 100% pure PLA can be used. And secondly is that even the waste is collected, it has to be stored in a dry box. Companies have stored their waste on open air, so the material becomes very brittle and cannot be processed. And thirdly is that the waste has to be shredded, and after shredded, it has to be pelletized into a homogeneous shape as to ensure uniform processing. First step of this study is the collection and segregation of waste PLA material. Waste are collected from 3D printing companies, Gaia Pebbles, AA3D, 3D Gens, and also Innovation Lab in FKM. It is important to ensure that the waste is 100% pure PLA, as certain PLA filaments, PLA plus or Polymax, are added with additives such as calcium carbonate or arclate polymers. The waste needs to be stored in a dry box as shown in the figure as to reduce moisture. The box is filled with silica gel and also it is airtight. Moisture can make the waste become brittle and reduce its print quality. This is an example of a waste PLA that is not stored properly, and it is so brittle and how it can be broken easily. Part is after collection, the material will be shredded or crushed into smaller granules in order to ease the process of processing of filaments. However, the material has to be pelletized, as pelletizing can help produce a homogeneous shape, which will reduce the possibility of filament extrusion machine to clog and also producing a better print quality. Before proceeding to the next step of processing, the pellets must be analyzed, and then only at Gaia Pebbles, there is a filament extruding machine where the pellets will be melted in the machine and pumped from the nozzle and cooled to become a filament. The filament specifications is going to be preset to 1.75 millimeter as the standard size, and after that it is analyzed again, the filaments, as before heat and after heat, the thermal properties has changed. And after the analysis and quality check of the PLA recycled filaments, then only it is 3D printed into a new product. There are 3 types of analysis that will be conducted in this study, which is firstly is thermal analysis, TGA or thermogravimetric analysis, and DSC, differential scanning calorimetry. And secondly is flow analysis, which is rheology analysis. These 2 analyses will be done on the recycled 3 PLA pellets and also recycled PLA filaments. This is because from the pellets, heat will be applied to extrude into a new filament. These 2 studies will study how temperature can change the thermal properties and also to study the viscosity and the strain rate. And thirdly is the tensile study for the finished product, comparing virgin PLA material and also recycled PLA. TGA studies the change in mass of sample due to the change in temperature, and TGA will provide the temperature of weight change, the percent weight loss or gain, and thermal stability. DSC analysis measures the amount of heat required in order to increase the temperature of the sample. DSC analysis can give information on the heat capacity, the melting temperature, and the latent heat of melting. These 2 thermal analysis is important to be done on the waste PLA filaments and the pellets as to see how different temperature can change the thermal properties. This is because heat will be introduced in the filament extruder, so the properties of the filaments and the pellets are different. This can also determine the cycle of how many times the PLA filaments can be recycled. Next, the analysis that will be done is flow analysis or rheological analysis. This flow analysis is important in finding the viscosity, which is related to shear thinning. Shear thinning is a plastic phenomenon, and theoretically, if a fluid has a high viscosity value, it has a stronger shear thinning behavior than a fluid with a lower viscosity value. Okay? The analysis that will be done is tensile testing that will be done on the final 3D printed product from the fabricated recycled PLA filament and from the virgin PLA filament. Tensile tests can determine the Young's modulus, the ultimate tensile strength, the yield strength, strain, and the modulus of elasticity. This is to compare the mechanical properties between the virgin filaments and the recycled filaments, and the hypothesis if virgin filament is better than recycled filaments. In conclusion, recycling PLA filaments can have a number of benefits such as reducing environmental impacts due to 3D printing, reducing waste, reducing production costs, and conserving natural resources in order to create a circular plastic economy. However, there are a set of limitations and challenges that will be further studied in FYP2. Thank you very much.